In the history of technology, few companies have reinvented themselves as radically as NVIDIA. Today, it is the $4 trillion engine of the AI world, but its journey began in obscurity. To understand this empire, we must look beyond the stock price and the gleaming data centers and travel back to 1993, to a roadside diner in San Jose where the air was thick with smoke and ambition. It was at a Denny's where Jensen Huang, Chris Malachowski, and Curtis Priem sketched out a vision that everyone else thought was impossible, bringing 3D graphics to the personal computer. At the time, PCs were boring office machines used for word processing. The founders believed that one day, these machines would become the ultimate consumer device for games and multimedia. They launched their first chip, the NV1, in 1995 with high hopes, betting on a technology called quadratic texture mapping to render curves, which was mathematically elegant but practically fatal. Disaster struck when Microsoft released DirectX, a standard based on polygons, triangles, not curves. Overnight, the NV1 was incompatible with the industry's new direction, and sales plummeted to zero. By 1996, NVIDIA was facing its first death. They had burned through their capital, laid off half their staff, and had only enough cash in the bank to keep the lights on for 30 more days. Their only hope was a contract with Sega to build the chip for the Dreamcast console. But Jensen Huang knew their quadratic technology was wrong and would never deliver the performance Sega needed. In one of the most pivotal meetings in corporate history, Jensen flew to Japan to meet Sega CEO Shoichiro Irimajiri and did something incredibly risky. He told him the truth. He confessed, "I cannot build the chip you need. We are going in the wrong direction. You should find another partner, or your console will fail." It was a confession that should have ended the contract. But then Jensen made a desperate request. "Even though we cannot finish the contract, I need you to pay us the full amount anyway, or my company will go bankrupt this month." Miraculously, Irimajiri-san agreed. He invested $5 million into NVIDIA, not for the product, but because he believed in the team's honesty and potential. That money bought them 6 months of life. With this final lifeline, the team scrambled to build a new chip, the Riva 128, abandoning their old technology to embrace the new industry standard of polygons and triangles. They were moving so fast that they had to write the software drivers for the chip using a simulation, before the physical chip even arrived from the factory. It was a total gamble on execution. When the Riva 128 launched in 1997, it was a massive hit, selling 1 million units in just 4 months and propelling NVIDIA out of the danger zone and onto the public stock market. But survival was just the first step. In 1999, they launched the GeForce 256 and coined a term that would change computing forever: the GPU, or Graphics Processing Unit. This was the first chip to put transform and lighting engines directly on the hardware, offloading complex math from the CPU, and allowing game developers to create worlds of unprecedented realism. This innovation was a knockout blow to their fierce rival 3DFX. Within a year, the once dominant 3DFX collapsed, and NVIDIA acquired their assets, becoming the undisputed king of PC graphics. However, Jensen Huang had a vision that went beyond video games. He noticed that the math used to render pixels, massive parallel processing, could be used for scientific problems. In 2006, NVIDIA made its second bet-the-company move with the launch of CUDA, a software architecture that allowed anyone to program the GPU for general-purpose tasks, not just graphics. This was a controversial decision. Adding CUDA support to every consumer chip increased the cost of manufacturing, meaning NVIDIA was essentially subsidizing supercomputing features for gamers who didn't care. For years, Wall Street punished them. Analysts screamed that NVIDIA was wasting money on a niche academic market, and the stock price stagnated as profits were poured back into R&D. From 2008 to 2012, the company struggled to explain its vision. Revenue from this new computing segment was tiny, totaling $0 billion for years. Yet they kept investing. They traveled to universities worldwide, giving away free GPUs to professors and researchers, planting seeds in the academic community, and creating a generation of scientists who only knew how to code on NVIDIA hardware. The turning point came in 2012, from a research lab at the University of Toronto, where a team including Ilya Sutskever was working on a computer vision competition called ImageNet. They utilized two NVIDIA GTX 580 GPUs to train a deep neural network called AlexNet. The results were shocking, beating the competition by a massive margin and proving AI actually worked. Jensen Huang saw the paper and immediately understood the implication. The parallel processing power of the GPU was the missing key that artificial intelligence had been waiting for decades to find. He gathered his executives and announced a total pivot. NVIDIA would no longer just be a gaming company. It would become an AI company, reorienting every product line to support deep learning. This led to the creation of the DGX-1, the world's first AI supercomputer in a box. In 2016, Jensen personally delivered the very first unit to a small non-profit startup called OpenAI. Elon Musk, a co-founder of OpenAI, signed the box, marking the beginning of a partnership that would eventually lead to the development of ChatGPT and the modern generative AI revolution. But hardware was only half the battle. To build truly massive AI models, thousands of chips needed to talk to each other instantly, and the existing networks were simply too slow. Identifying this bottleneck, NVIDIA acquired Mellanox in 2020 for $7 billion, a move that secured the best networking technology in the world and allowed them to build data center-scale computers. This full-stack approach, chips, networking, and software, created a formidable moat. Competitors could copy the chip, but they couldn't copy the entire ecosystem that NVIDIA had spent 15 years building. When the generative AI boom exploded in late 2022, NVIDIA was the only shop in town selling the picks and shovels for the gold rush, and their H100 chips became the most sought-after commodity on Earth. Tech giants like Microsoft, Google, and Meta began buying every GPU they could find, engaging in an arms race that propelled NVIDIA's revenue from billions to tens of billions in a single quarter. By 2024 and 2025, NVIDIA had transitioned to the Blackwell architecture, a system so complex it pushed the boundaries of physics, designed to train models with trillions of parameters. However, heavy is the head that wears the crown. The company now faces the innovator's dilemma, as their chips have become so expensive that customers are desperate for cheaper alternatives. Google has developed its own TPUs, and Amazon its Trainium chips. These custom processors are specifically designed to run AI models more efficiently than NVIDIA's general-purpose hardware. There is also the threat of software. Open-source frameworks like PyTorch are making it easier for developers to switch away from NVIDIA's proprietary CUDA platform, slowly eroding their software lock-in. Geopolitics adds another layer of risk. With strict U.S. export bans preventing the sale of top-tier chips to China, NVIDIA has lost access to a significant portion of the global semiconductor market. Furthermore, the entire AI economy relies on Taiwan Semiconductor Manufacturing Company, TSMC. Any disruption in the Taiwan Strait would bring NVIDIA and the global tech industry to an immediate halt. Despite these towering challenges, NVIDIA remains aggressive, operating with a philosophy Jensen Huang calls intellectual honesty, the willingness to tear down successful products to build the future. They are already looking beyond the data center to the next frontier, physical AI, or robotics, where they aim to provide the brains for the humanoid robots and autonomous machines of tomorrow. Project GR00T and the Jensen Thor platform are their bets that the next wave of AI won't just generate text or images, but will walk, talk, and interact with the physical world alongside us. From a smoky diner to a $4 trillion giant, NVIDIA's story is a testament to the power of resilience, long-term vision, and the courage to bet everything on a future that no one else can see. As the world races toward an uncertain technological horizon, one thing remains clear. Whatever the future of computing looks like, it will likely be built on the foundation that NVIDIA laid. The story of NVIDIA is far from over. In the words of its founder, they are always 30 days from going out of business, a mantra that keeps them running faster than anyone else in the game. This relentless drive is what turned a failed graphics card company into the architect of the modern world, proving that the biggest risks often yield the greatest rewards. So the next time you see an AI generate a masterpiece or a car drive itself, remember the 30-year journey of near-death experiences and bold gambles that made it all possible. The engine of the future is running, and it is showing no signs of slowing down.